Contextual compression helps improving your retrieval accuracy and quality by re-ranking and filtering results based on the query context. So how it helps? It basically, let's say you pass some query and some document has, let's say, 10 or 20% content related to that query, and rest all 80 or 90% document stuff are mostly unrelated or not uh, contextually related to it at all, right? So in that case, contextual compression algorithm helps you by re-ranking and filtering the used part and filter out the rest of the parts. So if you see here how to build a contextual compression retrieval algorithm, so you can see what we are doing here. We are creating one pair compared to the content of every pages that we have inside the document and the query. Once the pair is created, we are converting it into some tokenizer based on some, we are using Hugging Face, so some Hugging Face tokenizer, we are using this auto tokenizer, right, for doing the tokenizer. Once the tokenization is done, so we are truncating the length that's crossing 512. We are doing some padding and we are returning PyTorch tensors. Okay, so once that is done, as we are interested in inference and not training, so we are disabling the gradient, and then we are getting the compression model. Okay, so once we are getting the score from applying this compression model, we are returning the output scores basically. So we are sorting the documents here by scores and we are returning that compressed documents. So if you apply the same contextual compression algorithm for retrieval, instead of previously, here you can see we have used multi-query retrieval, right? So what will happen if we see applying the question remains same, right? How to trade with insiders. In that case, after applying contextual compressions, you can see it is returning the content that actually contains information regarding this insider trading with the markdown. So as you can see, this insider pie, that what we are looking for, right? This script provides interactive dashboard for analyzing insider trading data. It includes topic modeling using BERT, NMF, LDA, visualize data using network graphs and blah blah stuffs, right? So this content, this retrieval algorithm, which is our contextual compression, it brings from the pile of data or pile of document, and before compression, these are the documents that it is retrieving. So it is retrieving this insider.py document. It is also retrieving documents from trade order management system. But if you see in the current context where we have asked, the question is how to trade with insiders, right? In this context, these documents are mostly irrelevant, right? This trade management system and all. So we are only interested in this insider.py that got compressed and extracted. Okay, and if you see here in our PCA analysis, you can see this is where our query resides, and this is where the document, all the document resides. So this is how you